Hello everybody, this is Mr. Bowen. Today we're going to be looking at the ALEX topic, solving a percent mixture problem using a system of linear equations. So we're going to do this a little more traditionally and not use a system of use the system of equations directly. It is in there, but it's a slightly different way of setting it up, and I think it makes it a little more streamlined, a little simpler to see what we're doing here, because these are a little weird to think about. So what we have is we have a scientist that has two solutions, which she's calling solution A and solution B, so they don't get mixed up. And each one is mixed with salt. She knows solution A is 70% salt and solution B is 95% salt. And she wants to retain 110 total ounces of a mixture that's 85% salt. So she'll mix those to figure out. We just want to figure out how much of each she should use. You will have a calculator in ALEX, so you're welcome to use that if you need to. Which I would highly recommend with some of these problems. If nothing else, then at least to check your answer. So how we're setting this up is we want to think about what we're really looking at. So we have some amount of this solution A, right? And we're going to mix that with some amount of solution B. And then that result, after I mix it, is going to give me a amount of solution C, right? So there's a couple things that are in here, right? If it's a mixture of 70% salt, that means that it's 70% salt and then the other 30% with just water. And same way here, this would be 95% salt and 5% water. So if I think about this, I'm actually going to set this one up in terms of how much mixture I'm mixing and specifically how much salt, because I want this to be 85% salt. So since I know how big this is at 110 ounces, I can figure out how much salt I need total. Okay, so setting this up, so if I'm looking at solution A, solution B, and we'll just call this solution C, which is our mixture. So I guess I'll just call it the mixed one. Okay. So let's see what's going on here. All right. So how much solution? So the amount we're going to put here. Then the percent, just for you'll see why we're going to need that in a second. And then the amount of salt specifically is what I'm going to try to figure out how much I need. Okay, so just filling in somewhat things I know here. I know I need 110 total ounces, and I know solution A is 70% salt, which I'm going to put as a decimal, I think, for ease of explanation here. Switch that now, and then solution B is 95%, and I want my result, my mixture, to be 85%, so 0.85. That's all I know at the moment. Okay. So to figure out these amounts, I'm just going to call one of them X, and you traditionally call the other one Y, but it's kind of a waste of time since I know my mixture has to be a total of 100. If I put X amount in here, this one's going to be 110 minus X. Okay, so if you think about this, if there's 100 here, when you subtract here, you get 10, so 100 plus 10 is 110. If I put 50 in here, 110 minus 50 would be 60. 50 plus 60 is 110. So if I call this X, this will be whatever's left over to fill it up to 110. Okay. Now, to figure out how much salt I have, let's look at the mix first. I just take how much of this I have, and I know 85% of it is salt, so I just multiply those two things together, and I can figure out how much salt I have. So 110 minus 0.85 gives me 93.5 ounces, I believe. Yeah, we're measuring in ounces. And I'm going to do the same thing here. It's just not going to work out as nicely because I have variables. So I have 0.7x, and here, this whole thing is treated as being in parentheses. It's a single unit, so 0.95 times 110 minus x. So to figure out my equation, I just need this column now. Okay. So I'm going to make my equation as 0.7x, that's how much is in here, plus 0.95 times 110 minus x equals 93.5. Okay. So now we just need to do some quick math here to simplify this one down. So I'm going to distribute here 0.7x plus 0.95 times 110. 110 is 104.5 minus, that one's easier, 0.95. X equals 93.5. So these two are like terms, and then I'll need to move that over there. So, but first, 0.7x minus 0.95x is going to be negative 0.25x. And then here, subtracting the 93.5 minus 104.5 should give us negative 11. So then I'm going to divide by my decimal here. Okay, so I have negative 11 divided by negative 1/4, or just multiplying by a quarter. Oops, sorry, not x supposed to be there. So I want the x to stay, and that gives me a total of 44. So what does that mean? It means I need 44 ounces of solution A. So then do I have to go through this whole thing to find solution B? No, it's just 110 minus that. So just quick math here. You end up with 66. So 110 minus 44 ounces of solution B.